Right, so just checking that I've gone live somehow. Let's go into yeah. Right, so I'm not sure where it exactly is. Oh, in fact, I've just got a link to the section where it's at. So let's just see. It's live. So if I click on that link, right. So I'm not sure where it exactly is. There we go. Right. So I can see myself in live mode. So what I'm actually going to be doing. This is another Python video. And I don't have a section in here, so I'm probably going to. I might make a section called. We've got AI now. There's no little section here. I actually thought I had a maths section as well, so I don't think I do. But it probably belongs in. Let's see if I've got it here. Methods. No, neural network. Object oriented. Don't even know what that piece is. Okay, no, fine. Ah, that was a composition over inheritance video, or at least little test or tutorial. Data type, comment, environment. Okay. Scope, private, protected, access. I'm not even sure of being there, no, because that's about classes still. Import, built-in modules, external modules. I mean, I guess it's going to fall into this little section, which is user-defined modules. So, and what is a user-defined module? It's something that you create yourself, and it's just another way of organizing or like modularizing your code. Now we can put things into classes, and the alternative is that we can create like our own little like Python file. The Python file will have a name, and then we can reference the Python file. So that's actually what I'm going to be doing. And let's see if I've got any other stuff there that's of use. Okay, there's some stuff here. I went through this, and I'm going to actually have a look at like this maths GCSE paper. But actually, one of the things is, or not this particular paper, but one of the things is that there's like formulas and so forth, like standard formulas. And I was like, and my 16-year-old, she asked me, to help her with her GCSE, and I was like, okay, a lot of this stuff is like, it really is standardized and it should be in the formula sheet and so forth. And I want to kind of like show how easy it is, but I'm going to combine this with AI. I think that's the interesting bit. Now, I did a couple of other AI things, and just bear in mind that everything that's done here is completely live, so there isn't any pre-preparation or anything. So I'm going to make everything visually kind of like in front of our faces. So in a previous video, I did this test quiz, and it's still lingering around from like a week or two ago. Where I went in and I asked the AI, and I'm going to use the AI here. So I'm going to use the AI, which is what's the name of this particular? It's Copilot. Sorry, I should know that. So I'm going to use the AI to create something new, basically. Now I could actually I could actually ask from inception, but I'm going to do what I believe to be the minimalist amount of work. So I'm going to create a new folder because I haven't got one of these, and I'm going to call it math module. I actually just call it maths. There we go. Right. And I'm hoping that it lives in the same level as physics. So there we go. We've got maths and physics, and in the physics module, there was a bunch of stuff in there. So, and I think I did a couple of these videos, so forth. So they were, how to use Plotly and so forth. But now we're one level up, so we're going to do maths, but we're going to be really, really lazy about this and see if we can do this particular one in the form of AI. So I'm going to make a file called math underscore GCSE.py. I probably don't even have to create this, right? Because I've got this little piece here, the control I, to ask some code to do something. So I don't have to do control I, I'll just click on it because it's there. And I'm going to do something like using the formula sheet from GCSE Math. Using the formula sheets from GCSE Maths papers, I wonder if I can do control return. Yeah, I can. So I'm just going to move on to the next slide. Make a module or make a set of functions that contain all the likely or expected formulas. For example, I'm going to throw in an example. The area of a circle for Pythagoras, assuming I spelled it right. And I think that's basically it. Using the formula sheet from GCSE, make a set of functions, and so forth. And I'm just going to hammer the return button because I think it's good to run. And it's thinking because we can see the 3 dots. This is kind of like the beauty of the new world, basically. Let's say we're in 2025. I'm not even sure that this level of existence existed in 2020. It didn't even exist literally until a year or so ago. I guess there were paid versions that might have done or had a better go at this, but we'll have a look now. It's put in a bunch of formulas. It's made 60 lines of formulas. I wonder if there's anything more to do. We've got some areas of triangles, but it's got an area. It's got area of triangle, area of rectangle. Okay, fine. Area of trapezium, volumes of cylinders. The quadratic formula, that's quite nice. Minus b plus minus root b squared minus 4ac all over 2a. Just showing off my math skills there. I could add some A-level things. I'm wondering if there's anything missing, because these are all very basic. But in any event, I guess I can hit this. So distance equals speed times time, def time. That's not really. I'm not sure that I like this. Although they put it's been put into a little section. I guess here, if I can do control I don't know if this begins in a class. And in fact, they're all segregated. So like this density, mass, volume, again. That belongs in a class. That belongs in a class maybe because they're related functions. And actually, even we could say that area functions belong in a class. Volume functions belong in a class. So we could possibly do better. So out of the bat, we've got 60 lines of code. And I could call it from within this function, but more importantly, I guess I can make this new module. So I'll just go into here and do new file, test math.py, right? And in test math.py, I'll do import math GCSE as mg. Right, that should do. And why have I done that? Well, we can see straight away. But anyway, we can just do now. This import allows me to, with the alias, so import math GCSE, I'm going to zoom in a tiny bit. Maybe I'll even close this sidebar because I've got the two things that are open over there. So get rid of that and zoom in a tiny bit. Right, Control Plus, I'll zoom in a little bit more. So there we go, import. So we've imported Math GCSE and there's our alias MG, and that lets us just expose. In fact, here I could put is Math GCSE is imported but not used. We're about to use it, but I can expose all the methods and attributes. At the moment, I've got no attributes, but I've got methods because it created lots of methods. So MG dot, and then these are all the methods that are available to us. So like I could get the area of trapezium. So I could do something like, without even knowing what I'm going to do, a control I believe it was, example for getting the area of a there we go. Because I'm too lazy to even type it, hit return. Let's see what Copilot does for us. Yep, there we go. So we can actually be this lazy. You needed to have a base. Well, you needed to have two bases and a height, I guess. So the length of the first base, the length of the second base, and then the height of the trapezium, and that was sufficient. Now in here I can hover over it, and it's got A, NE, B, NE, height, NE, and it returns as a type NE. Now I think that I would want to type hint, so that's one of the things I want to do here. So because I don't want any, this has got to be a float, 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 and a float, and return a float. So here I wonder if I could Control I, in fact, type hint the functions. I'll just leave it as that. I was going to type in the functions in this module, but maybe that should be sufficient. Tuples and unions, and from typing, okay. Have a look if it put anything in. No, it hasn't. Hasn't done anything, in fact. That's of any use. So, closer. Wonder if I can do that. Yeah, maybe I can. So let's just see what this does. That's better. So define area of radius. The radius is of type float, so it knows it's float, and then it returns the float and so forth. So I hit accept. But what I actually want to do is, and I could have done this in a different way, but I'm just going to do this because I actually quite like it this way. In fact, I wonder if I can click stars do show code actions, modify using Copilot, review your Copilot. I'm just going to, I could do that, but I can do this. Now, I just type in, let it do the damn lot. There we go. And banging it all out. As it's going quicker, you can see the little mini map on the side, and it can kind of like complete itself. So it's done everything, and I hit accept. And I wonder also, I mean, when I do control and save, this is like, now I've got the rough linter as well, so control F, let you see, but well, I guess we wouldn't get to do very much, but a linter will take place along with this linting stuff as well. So now when we go back in here, when I hover over the A, well, that's the type float, and then the height is the type float. So I guess here area of trapezium, if I was to go back, I wonder, for example, is that descriptive enough? Control I. Avoid single. I actually watched the video on this myself earlier today, funnily enough, when I was at work, which is naming. So avoid single letter names. Single names. Use proper, or I call it variables rather than names. See what happens here. I've got no idea what's going to happen here. I'm presuming, I'm hoping that, there we go. They're beautiful. So we just hit accept. Now here for the cylinder it was fine. Fine. Now here, this is an interesting one because these might belong in a class. So they may or may not, because it's a group set of functions. So, and what do I mean by a class? Let me just hit Control S there so it works. So there, that's the area of a trapezium. So that's for areas. Now I might have a whole set of. I wonder what that like. It's actually doing stuff for me. Right. Okay. So let's just pull out one of these, but like for example speed. Okay, so I could do calculate. Now there's a different way of using the IntelliSense, the speed. Given distance and time. Fantastic. Look, it's doing all of the guesses. So, and then I hit tab to get more. So it's got the distance, hit return. Yep, it's got a little bit of time in there. It used 9.58, some sort of acceleration due to gravity by the looks of it. And then tab that, and it gives an example of how to use the speed and time. And I guess that's it. And then print F, there we go. And then we can actually run it. I didn't actually run this code, so let me just run this code, F5 to run it. And we should see our answers down here. Yep, there we go, so that's running. Our answers are just down the bottom. So I think if I do double control, I think so. There we go. That's one of our answers, and that's the other answer. But I want some rounding here. Look at that ugly thing. The speed is this, and I want it to four decimal places. The other thing is, so I can call this function, but really, I guess that these speed distance equals speed times time belongs kind of like in a class of speed and times. So because they're grouped, they're like related functions. So I'm just going to do something like this, and I wonder what it does. Put this section into a class. Now I wonder, look, I can even put like double spaces, it's going to read it, it's great, fantastic. Put this into a class. Now I wonder what it's going to, if it's going to give a nice class name. Section of related functions into a class. Let's see what happens. Right, so this is class speed, distance, time. This is class speed, distance, time. Then we can, so I'm going to hit save. And I'm going to do the same thing again. Now, because mg.speed doesn't exist, so let me actually comment this one out and then do and this doesn't exist either. We got a little red hint, and if I hover over it, it will show me it's undefined. Speed is undefined at the moment. The rough linter has decided it's not defined, and so by the way, if speed is not defined, pylons, like all of my editors, they don't like the fact that speed isn't defined. All of my linters don't like the fact that speed isn't defined, but we are going to do using speed distance class to calculate the speed. Tab, and then tab again. There we go. So this is a speed distance class. I wonder, I don't know, like what kind of like, what is better? Is it better to classify or put these related functions into one thing? So now, for example, alternatively, you can use a static method directly. There we go. So I get to learn, right? I wonder what this is going to do. Use the static method directly. Boom. Let's see what happens here. I mean, it hasn't done anything different there, so no. I will not accept close escape. Escape. I hit the escape key. So, you know, do we put these into classes with static methods? I mean, arguably we could do, then because then you won't have, like, if I had more functions, I'd probably need to segregate them. So one thing that I'm going to do though is I'm going to create a doc string. The reason why is, now I might remove them from the class. That's the piece that I'm thinking about. No, you know what? I'll keep them in here. What I'll actually do is doc string. Right, doc string for the functions. Let's see how we go. Oh my god, that's going to be a tiny bit ugly there in the sense that I'm wondering, apart from the fact that the indentation is not good, because double dot, I'm going to hit an undo, rerun. I actually wanted the class, but I wonder. No, that's too ugly. So I won't do an undo. I wonder if I can delete the stuff though. For me, yeah, I can, and I'm just going to hit the accept button. So, although, and it has, okay, fine. I might have to, it might make more sense. Or here actually, control like line, simple, short, doc, string. Let's see what it does. Yeah, that's kind of like acceptable. Okay, fine, we'll have that, because then, you know, when I save it and I go back to the math module, if I hover over it, it's a tiny bit ugly still. I guess that's because, in fact, I don't know why, because it should have taken the indentation. The space is underneath it. We learn an ugly doc. So go back, control set, go hover over it. Well, spaces seem to have done something. When I go in here, I'm kind kind of wondering what the cleanest way of doing it is, but like he didn't notice these, and that's maybe because of the colon in there. I wonder. You know what I'm going to do? Because I'm just using the AI to engineer this. I'm just going to go Control I, shorter. Doc string. Yeah, there we go. Okay, except much nicer, because then I can put a doc string here. So doc string, and all I'm typing is the word doc string. Let's see. Again, like, I don't want to go like overboard and go mental on this here. And also, why is that underscore there? Ah, because it went it went in front of the actual function. So that's nasty. Like, why would it have done that? Control. So I won't accept that. Close. I don't accept it. Is it because I positioned it in the wrong place? But I don't want a massive doc string anyway. Right, so I'm going to go kind of like here, and I'm hoping it puts them in the right place. I'll do that again. The reason why I don't need a full doc string and everything else is because the function signature is descriptive enough. So I just want to kind of like work out distance, work out speed, give time. There we go. So I've just done single line doc strings for each static method, hit return, see what it does here. No, it's kind of like put them in the wrong place again, so I don't like that. Now I could copy them out and paste them in, but instead I'm just going to do close, and so it's prompting me that I could actually do this. If time equals 0, then time cannot be 0 because distance equals speed equals distance divided by time, and we would hit infinity. Time cannot be 0 because you hit, because it would. I wonder what the rest of it said over there. Scroll across. Because it would cause a division by 0. Because it would be faster than the speed of light. There we go. Something like that. But we're not going to be doing that. So we raise a value error. I'm actually going to keep this little piece of code in. Now, the one nice piece is when you do this stuff in the module here, I can put all of this type checking and everything else in, so we can see how it works. But here, when we do, I think we had this speed function. So there we go. Time float. So now we could call this, but we can actually set time equal to 0. So time equals 0. Right, there we go. And then we could rerun the code. So F5 to run the code. I think there's a way of running, well, there is a way of running little block of code. And we get this time cannot be 0, right? So we raise an exception frequently. They're quite nice. We could do other things. So I might not want to have a value error there, but instead, although it's taking me to that code, we could have done if time equals 0. We could have done something like no such thing as 0 time or something like that. There we go. We don't have to raise an exception. We can sort of like silently pass through or just give the message out. I'll still put that in, time cannot be 0, but we'll just print it this time so we don't have to raise a value, but a value error. But the reality is that, well, we've handled our case in a way. We've silently passed, so go through here and then hit the F5 again, and instead of crashing, of course, oh, hold on, it should have returned. Actually, that's what I should have done. And then here I'd have to actually put, so let's be careful, that's the whole point of raising errors. Return, actually, time cannot be 0. Okay, I will return, we can return 0, I guess. There we go. We'll hit stop on that. The reason why I'm umming and ahhing about it is if I say return and then like none, for example, so if I put none here, then this function is actually going to return, any, because it could be a float or a none. So I'm actually going to put in 0. Or I could put -1. That's quite like a convention, like as in, I know -1 actually works. I was thinking of time for a second because you get a negative time, and then that would mean like kind of represent an error. So the thing about 0 is return. I'm going to add a constant, and I'm going to put the speed of light. There we go. That's what I'll do. So I kind of wanted to show that anyway. Constants, math.py, speed of light in a vacuum. There we go. Tab. I don't know if I have to do anything. I can be so lazy. So that's my constants. I won't keep that. I'll just leave that there because constants can be at the top. And then wherever that little speed was, so control F speed. There we go. I can go down here and now I can return C. There we go. Speed of light, and I think is 0. There we go. Return C. So now where's C from? Because C is not defined in the function, but that should be fine because it's in the global namespace over there. So it should be perfectly fine. It will be a math GCSE.C. So, and actually this is one of the attributes now. So if I was back here, I could actually go speed of light in a vacuum, and mg dot c is actually what I wanted. Print mg dot c. There we go. Now it's kind of like, in fact, I'll run it, or I'll put in, we'll make a little f string. Ooh, look, mg.c tab. I think we can just do that. That's done. And I'm just going to put the speed of light in a vacuum. And then we can just run this little piece of code. And this is now taking it. And this is the thing about it. This is now, and one of the attributes basically that we're calling, and it's giving it as an integer, and there we go, it's at the top over here. So if I do control, we just see the speed of light in the vacuum when it's come out there as an integer. Very nice, fantastic. So, and we also got time cannot be 0, and then we got the speed is, right, so we've returned a speed from our method over here, this distance equals speed times time. So we did it in a different way, just showing different ways basically. So we've done it in a different way. We've got a class, an example of a class, and when we hover over the class, it tells us utility class for speed, distance, and time calculations. And in this particular case, I haven't actually hinted this, but like work out speed given distance and time. So I might actually just throw that in there as well. So we'll go back down, Control F, and then do speed. There we go. And I think it might be sufficient to do. There we go. Ah, beautiful. It does some other checking as well. If distance is less than 0 or time is less than 0, yeah, because you can't have a negative distance. Well, I'm going to say you can have a negative distance. So in theory, the only thing you can't have, because negative distance would be going backwards, that's all. So you'd have a negative speed. It would actually be called velocity, not speed then, but your speed in the other direction. So you could have you can have a direction to that. So that's fine. But I like the fact that it's just done it basically. So anyone they push it down arrow, it just sort of like accepts it. So I can just do that. That's a nice thing. And this is just basically testing the AI anyway. Calculate distance given speed and time. Beautiful. And if time equals 0, time cannot be 0, return C. Now, distance equals speed time. Well, in this particular case, it's interesting that it actually does this, because time can be 0 in this particular one, but maybe I could check if time is negative. If time is less than 0, there's no such thing as negative time. But I want to, if time is less than 0, time cannot be negative, return. I don't have to return anything in a way, or just time cannot be negative, return. Well, the distance, what would, if, maybe just return a 0 distance. Assuming that you wanted to return a number, you might return something rather than do the raise value error. So we're not going to raise an error, although the reality is we probably should raise errors. So let's just remove this raise off the error too. And that's that. Now, look, one of the things is when you do this, it's almost like an autocomplete that's kind of like grayed out. So we're talking about, this little piece here that's kind of like slightly grayed out. Sometimes it puts you off, but I guess it's something that people get used to. It's all like if you ignore it, it just goes. Almost like, well, it's basically like an autocomplete in a way. It's the next thing that the AI is guessing using its tokenizations. So that's really cool, kind of like that. And then over here, if I press return, yeah, I don't even have to put in any quotations, and I hit tab, and this time I will time equals now distance over speed. So again, if any one of these was negative, so if speed was distance equals speed times time equals distance over speed, basically. So if speed was 0, then you would travel. So if speed equals 0, there we go. Sorry, it's right in there in the hints anyway, so I don't have to do that. I can just accept it. Look over here. If speed equals 0, print speed cannot be 0, return 0. There we go. As in we're returning, because we have to give something back. In fact, we're not really, because we're going to have an infinite time, I guess, because you've just never travelled. So I wonder if there's like a really, really large number tab. A very large number. There we go. Beautiful. Even better than expected. Now, like in theory, if it's a constant, then the constant should be capitalized. So really, that should have been math.bigc, and something very large number should be. So this is like a constant here. So the convention for Python, Control I, constant in capitals. There we go, very large number, except, right, and then this thing here will be C like that, and that means that there's going to be an error, but we see that here on the mini-map. So the mini-map's over here, this little piece here, we see this little thing, so we can go to it because it found our error. Or is it somewhere there we are, and that's going to be, it's going to say not defined and all the rest of it, because it's now capital C, because it's the speed of light in a vacuum. So we've got that, and then our maths, so we can sort of like hit save there. So, but we can see how we can get this really like elaborate, great, well documented thing in kind of like seconds. I don't think there was anything there, but this mg.c, that would have failed. It would have thrown an error now because it's mg dot and then capital C. Look, it's dummy. So again, yeah, we've got all of that, and when we hover over the function now, I was actually expecting, oh yeah, it does say it. Calculate the speed given distance and time. Beautiful. So we've got like our function, we've got the function signature, we know that distance is a float, time is a float, it returns a float, and then we've got a short little description of what it does. And over here it's a utility class for speed, distance and time calculations. So very nice, beautiful, love it. I did very little work in all of this. Also I did Control A to select everything. I was going to do Control S to save. And so now I could put all of these kind of like volume calculations into a like a volume class for all of the different because that's kind of like in a way what you might do, make a volume class. Let's just see what happens again. So Control I, make a volume class with volume formulas. See what it does. They're all going to be static methods again because these methods are just like, they don't need anything to do with the actual class itself. Although we could pull out, for example, radius, because you've got a radius of a sphere. What may or may not, I don't want to overcomplicate that, but there is basically, I observe a commonality which is radius, so radius could be a method, I guess, of this class, but I'm just going to leave it as is. And the nice piece about this, now this has done it in what I might call a slightly nicer way, is it's changed the volume of cylinder, or volume underscore cylinder now, and it's put the volume here and then cylinder here. So that's quite nice. I'm going to hit save. It wasn't save, actually accept. My mistake. There we go. So I've accepted it, and then here now, do we calculate? We calculated an area. So we'll just go here. There we go. I don't even have to do anything because it kind of like knows. Tab, tab, return, tab, return, tab. There we go. And it's done it, which is really nice, right? Which is this basically, oh, sorry, it can be totally lazy. Even lazier than lazy, right? It's done the docstring for me as well. So we've got this volume thing. Now, this is the nice thing about the class, which is mg.volume. And again, utility class for volume calculations. Beautiful. It's done the docstring. So if I just go here and then go to definition, there we go. It's docstringed it up for me this time using my original, I guess my original nomenclature, which is just to do a single line docstring, because we have all of the other stuff that is available for us. So these are all our volume calculations now belong in mg.volume, right? And then cylinder, it's got our nice little thing, calculate the volume of a cylinder. You know, I could put given its radius and height, but we can see that they are arguments into the function already. So if we wanted to calculate the volume of a cylinder, we've got that there for us. So great. I can keep on doing this. I wonder what else there was. So area calculations, and again we see 3 area calculations. So there we go. Control I again, and then put this into an area class. The functions. I probably don't even have to give it that much, but I'm being nice. There we go. It's done it again. Lovely. It's got maybe a few static methods. Now, the funny thing is I didn't know, well, I do know, but like, you know, if you don't like code in Python as often as someone that kind of like codes like every single minute of a day, you might not know the difference between a static method and a class method and so forth. But basically, the static methods, and again, the other piece is even if you didn't know it, you know, I guess I've got it. Have I got some stuff in Bard? I can pull up my Bard, but basically I can start a new chat. I can do anything, by the way. Control plus, let's just zoom in a little bit, like that. In Python, what is the difference between a static method and a class method? And just because I know it's going to talk and do a lot, go sort of like a short description. Otherwise, it's going to go on forever and ever and bore us to death. So the purpose of boring us to death is more about this video, which is designed to bore people to death. Watch it while he's sleeping. So there we go. In Python, both a static method and class method are decorators used to define methods within a class that behave differently from regular instance methods. So here's a short description. So the static method, it doesn't take the self instance or the class as its first argument. It's basically, it's more like just a group of functions that are sort of like related to each other. That's exactly what it is. It behaves like a regular function that happens to be defined inside a class. So that's exactly, again, what sort of like we wanted. It doesn't have any access to the instance state of the class. And that's kind of like what I was referring to, I guess, when I was looking before, because, you know, these, it could have been a class method, or we could have had like an initializer. So if there's commonality, now here there's no commonality, but when we did the volumes, it just so happened that radius happened to be there. So we might have made like radius sort of like a class method or something like that, or like a class like attribute or whatever. So instead of having a static method, we'd have a class method, and radius would be outside, and radius would be common to all of them. So given radius, I could calculate. In fact, you know, I don't want to do that. Okay, I'm happy to keep it as static methods because I think it's nice and clean, but I could have brought radius out here. So something like, you know, radius here. So we'd have to find an initializer, you know, that's got radius. So, which is something completely different, but maybe I wonder if I could have done it in a I'm just wondering if I could have done it in a data class. So something like that, or from data classes, import data class. So from data classes, import data class. So it'd be something like this. And the difference then being, I'm not going to do that. The difference then being that, you know, would I need the constructor, or, you know, the Pythonic version is the initializer. So anyway, on this, I'm still going to, I forgot to hit the accept button. It's done all of the comments and everything that I wanted. Hit accept, very nice, happy days. Now, oh look, area of a circle. That. belongs now, and this is quite a nice thing because it belongs in my area things. So it belongs here like that, and I guess I should be tabbing it in, and also I can remove that, and I can hit return, and it is a static method. So, oh, that's area of a square, not an area of a circle. Why did I have that in there? Okay, fine. It's throwing me in a method for free. I'll take that. There we go. Now, that's a static method. That's actually what I wanted to do. Ooh, did it have area of rectangle as well? Area of circle. If I just go here and then I was hoping, yep, it does area of a circle. There we go. And if radius less than 0, so it's going to throw me more stuff in. The radius cannot be negative. So the area is 0. There we go. Right, so, and I wonder if I go into here. No, it didn't. Oh, yes, it does. Look, your side. Side cannot be negative. Return 0. So I've got like some... I get free type checking. And the functions can be much more complete. Now, we've gone to like 116 lines of code. I've got to say, when I did this when I was at work, it actually knocked out. But I actually think that was because in my original description, I put like use type hinting and use doc strings. So, but anyway, that's looking quite nice. From the quadratic formula, I just wonder again. Oh, look, if discriminant is less than 0, I can't remember what the discriminant. Okay, fine. If it's discriminant less than 0, it's got no real roots. Return none. Now, this is the example here, so it does it for you, right? You're going to get back a tuple, which is two things, because you get the positive and the negative, or the lower square root, the higher square root, right? So there's two square roots to a quadratic equation. Or alternatively, you are going. It's actually there's no real roots. It is going to be roots. They're just going to be complex roots. But here, Python has chosen, or not Python, the AI has chosen to give you none. So I guess that's fair enough, given that complex numbers don't exist in GCSE Maths. So if I was doing an A-level module, then I would want this to be, that's going to actually still be floats. It's going to be complex. So complex numbers, which, by the way, Python handles. So I think it's just something like import. Is it complex? No. So let's actually just do this. I'm going to actually go in here as well because the short answer is there a module for complex numbers. The reason why I'm doing that, I wonder, and I don't know if it's going to do it or not, is that sometimes it'll actually build the code and so forth. So I'm just asking it a question there rather than attempting to build a code. Yes, Python is a module for CMath. It's called CMath. It provides functions for complex number operations such as square roots, logarithms, and trigs, and so forth. But anyway, we're not going to be using that. So I'll click that off. This is the little thing here. So and again, like I haven't used this massively. So open chat. This is kind of like my second time on this PC of using it. Inline chat editor, quick chat. But yeah, it's good enough. Now, some things are sort of like loose functions on their own. So in our test math thing, by the way, did we do a volume calculation? I don't know. I think we did. We did an area. So now the area of trapezium thing isn't correct anymore. So mg area of trapezium. I wonder what it does. I just selected it, see if it does it. Yeah, there we go. Accept. Oh, it's so nice. I don't have to do any work whatsoever. So it's done it. class for area calculations, and then here area of a trapezium, given its, the two bases and the height basically. So what does it mean by a trapezium? So let's go on to, just so that you're nice and clear on this. Trapezium. I'm only putting trapezium area because we're going to get these things. A and B, so it's going to be this length, and then this height over here. So I was actually thinking of a trapezium as being something slightly different, but that would be a volume of a trapezoid. So don't let me say that wrong. I should put half the base, half A. Well, it's not half the base times height. It's half A plus B times the height. So, I'm tempted to go into the deep maths of it, but there's no need to. If I was doing this, by the way, so if I alt-tab back, and if I was doing this in a notebook, I'd actually be able to copy the image and paste the image in, and like give the worked example. But I'm just doing it as as a test file, and the reason why is because when I save the changes, I don't, like in the workbook, I think you have to update it. So I'm not sure that just hitting save will update automatically. I'm not sure the workbooks are as good as that. They might have improved to that level. But in any event, like I didn't have to use this in the test math module over here. The other thing is, I guess, not that I've done it anywhere, but I could, this is good practice, I think, if double underscore name equals main. So this isn't the AI, this is actually my logic, but then I got def main. Okay, fine, yeah. Well, actually, that's going to do that, and then it's got the main guard idiom already, I think. Def main and the main guard idiom. There we go. Right, so this is the main entry point for the code. Imports go here, so I guess that's really it. So if I wanted to test some code, it would be in here, and then I could run it from here. But this, because I wonder even if I should even ever put that there. It's only for if you're testing inside of the module. So I'm actually going to leave this out because I'm never going to test from here. I'm always going to. So I'm going to remove that. Hit save. I'm always going to be testing for my test math thing. So, but if I was running this module and I wanted this to be the main module, it's almost as if, well, it is as if, not almost as if, math GCSE .gcse that I would want to do the if name equals main here. There we go. So it'd be something like this, and then, in fact, when I do the def main, I think this is just something that I had pre-set up. So def main. Right, there we go. Right. So I've got my main module. I don't know why I did that for a second time, but imports go in here. So this would now belong here in my thing. If I was like constructing this properly. Now, if I was a Java coder, I'd be forced to have done this because main is required straight away. So, but these bits here now, I guess I would bung all of this code for cleanliness X into, so I would never be running it as a script. I'd always be running it kind of like as functions. And the one thing I don't like about Python, which is I actually don't like the indentations. I've grown used to them, or I live with them, but when you're pasting things back in, you have to kind of like do the indentation yourself. And in other languages, it's kind of like the curly braces sort of like look after you to a degree. But anyway, something like this now I call a main code, and then it runs. Like the reality is, it looks identically the same. But then we could break our code down into its smaller bits now. So for example, over here, we don't need to return anything from the main function because we're not returning anything, but using the speed distance class. So here, this is all my speed stuff, for example. So def speed examples. Colon, there we go. I didn't mean to put the star in there. Example for calculating the speed. Look at that. So it's like, you know, calculate speed given distance. Right, so all my speed examples go here, and in my main then, at the end of this, like I call in any order, but we can see the speed examples. I can just call a function there. There we go, speed examples, right? And I'm going to do the same again for this one here. So this is volume. So I'm going to call this def. So speed examples will go. I'm going to actually move them up a level now. You gotta love the linters, right? Or the editors, not the linters. Right, there we go. And then def. And then what was this? Sorry, I forgot what it was. It was areas, right? We're doing volumes. Def volume examples. Yay, look at that. I don't even have to do anything, and I will call just before the speed examples, the volume examples. And tab, I don't even have to do anything still. There we go. Beautiful. So now I've got my volume examples, I've got some speed examples with all my speed stuff, and then I've got some other, I guess I don't know what else there is. Area examples. Yeah. So def area one. Look, I got to there. I got to there. No, I think I got to AR before it like picked it out. So there we go. And that means that if I'll move these up now. Right, and then here I'm just going to run area examples tab. There we go. All nicely done. So I've kind of like. I should go to the mini map, I guess. The mini map is this thing at the corner. So over here, I've got my speed, volume, and area examples. It's sort of like all nested and quite nice in there. If I zoomed out a bit, Control, just to look at the structure of the code, you can sort of like see this nice clean code. So you sort of like got our main function. I haven't like moved this piece out, but here's our main block of code over there. I mean, I guess Python's nice like this, which is like the indentation now looks nice. It's not so great for the copying and pasting, but there we go, our area examples, and then we've got our volume examples. So it's all like modularized quite nicely. And then I sort of like ran out of space on this. So, but in any event, I can all of that stuff. Speed examples. We just called the main function at the end of it, basically. If that's that's a convention. So yeah, it's just a lot cleaner. This is the main entry point for the code. Def constants examples. So tab. I don't want this bit on there, but I actually do want the example for constants. And basically here now, I can actually just move it. That sort of like belongs in there, but not the main entry point for the code, because that actually belongs back up here. But now I can do constant examples, and that's everything. So when I hit save, we can see that there's two spaces here. I think there's two spaces here. That's kind of like the formatting, but you can see here that there's one space. So I'm talking about the spaces here, this gap there. I should get rid of all of the other things. So Does that get rid of it? Yeah, get rid. And yeah, we're talking about this little like single line space over here. So when I do Control S to save it, that's going to turn into a double line space, because these ones here, all of the ones below, are double line spaces. So we're talking about here, we've got a double line space here, and then down below double line space. That's convention. That's what the rough linter is doing. So, or rough format, I guess is. So I'm going to hit Control S, or I can even do this, which is File. I guess, is there a save? Save. No, it didn't do it. Control S. Oh, oops, I did Control Return. Didn't mean to do that. I was expecting that to be saved. So let's go there. Let's have a look. Don't know why. Rough. Control Shift P is it for the command palette? No, don't know what happened there. Test. Don't know what happened there. Get rid of that because I'm not even sure what that was. I was going to do rough. No. No, it doesn't have it in there. I do have it installed somewhere. Rough Visual Code. Right, so that's the thing. Close that up, close that up. Show run commands, Control Shift P. Ah, there you go, rough format document. Well, I thought I was doing that, Control Shift P. So Control Shift P, there we go, rough format document. There we go. Okay, so it has done it. I thought the rough, but maybe it's not, but I thought it was on save that it does it, but it's done it now. But this this one line's turned into two, so it's done all of the formatting. It's put it in some sort of consistent way for me. So very nice again. I will just go here and get rid of these lines because they're not necessary. And Control S, and when we run the code, I've got a little dot somewhere. How annoying. Right there. Boom. Boom. There we go. Got rid of that. Control save. So when I run the code now, which is F5 to run the code, you know, it goes through and it does exactly all of the same stuff, but our function's quite nice. So we've got the speed of light in a vacuum because that came from the constants examples over here. Then we've got the area of a trapezium because we did our area example. So that was this little bit here that spat something out, and then the volume of the cylinder because we banged in a volume example. And then we had time cannot be zero because we did something where we put in a zero time over here. We overwrote a zero time. So time can't be zero, and then that returned us some sort of very fast speeds, and we didn't do the but we could have banged in another like speed calculation, or what we're now calling a speed distance time utility class like function, so we can calculate any one from the others. So the exact there. Funnily enough, but that actually exists in my physics thing, I think, somewhere, because I've got a force mass acceleration, but I almost wanted somewhere here to have def underscore example. That was my example. That there's three things in here that you get: force, mass, and acceleration. That's very similar to distance, speed, and time. Like there's a lot of these like relationships in physics where it's like one thing is equal to like two other things, like the product of two others, and so forth. The triangle kind of functions. But what's interesting, like, say it's a float, but I allow that a nun's in here, and then a float, and then a nun's in here, and then a float, and then a nun's in here. So you can have like a force, or you can choose to have a force, but you don't have to have a force. You can have a mass. You can choose to have a mass or not. But whichever one is not there, it knows from the other two. So it does a couple of little checking things. I wonder here why comparison to none should be cond is none. That's interesting, but this is something new because I guess I'm using a rough linter now when I wasn't before. So maybe I could um, quick fix Copilot, fix using Copilot. That's interesting. You should replace all occurrences of double equals none to is none. I'll close that for now because that's not what I want about. Let's just do that again actually. Fix using Copilot. Right, with 40. Right, so okay, you know what? I'm going to hit accept. Hover over this one. Fix with Copilot. I'm so lazy that I'm actually going to do this. Fix with Copilot. Okay, accept. I'm fixing my code live. Fix using Copilot. So put the is statement. So instead of accept, there we go. So it's corrected me. Like I would never have known that. But funnily enough, it's got if acceleration equals none. But anyway, the point being that it looks at this. Oh, it's checking if acceleration is zero because otherwise it will give you an infinite mass. But it's looking in here and checking which one doesn't exist, and then I'll go and work out the other the final one from the other ones. Now I'm not going to do that in this particular thing, otherwise the video will end up being 10 hours long in this test.math. But basically, it's kind of like the same thing here is true, which is in these speed examples, so in this math thing here, you can see that this distance equals speed times time thing is really what I want to do is have one function that's got three things in there, and one of the three things is none. That's the one that we want to compute. And let Python do all of the rest. Now I can do it in the AI, but I'm not going to do it here at the moment just because it's kind of like build something that's sort of like relatively clean. We've tidied it up. And I guess the one piece to look at really is if I zoom out and go to do, I guess I should do Control minus just to look at the formatting of it. So we sort of like got an area class, then we got a volume class, then we got a speed, distance, times class. I'm actually going to go to the run commands here and format the document as well because we want it all kind of like formatted nicely. But we've got our classes with our static methods in here. Area of square, area of circle, triangle. So here, do we want it to be the area of a square? We know it's area. So this thing here could now just be square, and this one here could now just be circle, right? Because we know it's the area, so we don't have to do area of square. It's area, and so I'm going to hit save on that. Go back here because I wonder if there's any area calculations in there. Area examples, and it's got area.trapezium, so it worked on that. But if I wanted to do the area of a square, now it will do it like as in mg.area. And then it will it's predicting that I'm going to ask for a trapezium, but actually I'm going to do square. There we go. Right. And it's even given an example using the negative thing here, but we don't want a negative one, and it will throw out the answer and so forth. But like I could put all of my area examples in here basically. No need to add more. So that's that. But yeah, I was going back because it's sort of like nice having everything in classes. And this here is densities. So so this should really be, again, it's kind of like density, mass, volume calculations. In the same way that we've got distance, speed, distance, time, this belongs into a class. So I guess go I put. This is actually physics, not maths in a way, but you know it's good. So although it does come up in maths GCSE, so into a class. Let's see what happens when I do that. Oh, look how nice that is. I didn't have to do anything. I wonder if I can do tab to accept. Tab, tab, tab. Oops. Shift tab to go back. Accept. Don't even have to touch the mouse. Beautiful. And then I'll hit save, go over to the next one, and then do like a function. So def density. Yes, it does do it. Beautiful. Pure laziness. And then we can hit F5 to run our code. Oh, I don't call it, by the way, so sorry. Go back and take that. Density examples tab. It's like the auto completions and all of that. Control Shift P, rough format document, Control S, F5 to run it, and math.gcc has no attribute density. ng.density. Okay. Hold on. Panic stations. Math GCSE. Ah. So it's going to be that. So you failed on me. Oh no, it has done that. Ah. Boom. It'll be that. So if I rely too much on the AI, so hit that. Let's just see. So we've got a mass and a volume. Example of calculating density. Example for getting density of an object. The thing is if I put a space here and then I do the Control Shift P for the rough linter, yeah, it keeps the spacing, so that's quite nice. Okay, because I wouldn't want that. Like I want it to come like a little gap. But let's just run this now, because now we've got the mass density volume thing over here, and our mass and our volume. I wonder, because it's got mass as a literal, volume as a literal. Is that because it knows that these are literals? Yeah, okay, fine, these are literals. So here, this is an float. I wonder if that's better now. It still has a literal 10. I wonder, like, I was expecting, I guess, this to be float. Like when we hover over here, hold on, mass density volume, dot, and then, right, and the density, that's better. Okay, right. So, density, yeah, there we go. So, mass is a float and volume is a float. Here, when you hover over it, like, what does literal mean? Like, literal, I guess this is literal 1 and this is literal 2. No, this is literal 10. Ah, okay. I'm just going to ask the question, what does literal mean in Python? So let me just get this back. What does for example, mean in Python or in the VS Code editor? Like, as in, I mean, kind of like, you know, this is like an integer of 10. It's just interesting that the word literal is always used. Now, I've never ever asked this question, funnily enough. So there we go. Let's just see. I should have put like answer in a short way. In Python, literal 10 is a type hint. Okay, so it's a type hint. Introducing Python 3.8 from the typing module. I don't use a typing. Did I use a typing module here? No, I didn't. Okay. It means that the variable or function parameter annotating literal 10 must have the exact value of 10. Here's a breakdown. Type hinting Python dynamically typed language that, but type hints allow you to specify expected types. So the funny thing is that I wanted it to be a float, but I think if I still put float, I guess the clues over in this piece here. This helps with code clarity, maintainability, and enables static analysis tools like linters and IDEs to catch potential errors before runtime. Typing.literal is specific typing. See, I didn't call it literal though. Typing that allows you to define a type that can be one of a specific set of literal values. These values can be integer strings, booleans, and okay, fine. So basically, it's saying it can be any of those things. And here it's saying literal 10 in this case means the type is int because it is an integer. But how I would expect wanted to have seen it's like say int 10. But more specifically, the value of that integer must be exactly 10. It cannot be 9, 11, or any other integer. Okay, fine. So I'm saying it's literally the integer of 10. That's what literal means. In VS Code, when you use literal 10 or any other type integer in Python code, especially with its Pylance extensions, which is what I'm using, which is a powerful language of Python, will leverage this information. Autocomplete and suggestions can offer more precise information. So linting and error highlighting. If you try to assign the value that violates a literal, type in VS Code also. Okay, fine. VBait, for example, if you have x equals literal 10 and then try to assign x equals 5, VS Code flag it. Okay, so yeah. So I couldn't do int, I don't think. Like, so when I still hover over it, that's literal, yeah. Okay, fine. Anyway, Control S. I guess I should just test the code and run it. It should all run fine. And then we've got our density calculation down here at the bottom over there. So that's our density calculation now. So everything's hunky-dory there. So Control save that and then go back to the Maths GCSE. And yeah, so kind of like most things are now. There's other functions here, and like I don't know if they belong in a class or not because the quadratic formula, so that doesn't belong, you know, next to the like circumference, but it's a Pythagoras. It doesn't really belong with Pythagoras either. So these are kind of like, you know, I could make a section of like general formulas, but that wouldn't be as useful, should we say. I could stick the generic formulas kind of like, or this one at the top, and everything else is classes. So X, there we go, and bang it right at the top somewhere here. And that's only for the purpose of ordering things nicely. So format the document, there we go, nice. And you know, I mentioned, but I have mentioned it before, Python is 79 lines of code, which is, you know, this piece here. But the rough linter actually allocates, it uses the black format, and it lets you actually go somewhere to about, I think here, like where my mouse is, which is I think 88, because modern editors allow for much bigger screens. So you know, you've got high definition and so forth. So there's 80 lines of code in the Python Zen of Python, I think it's called, is kind of like a legacy for many people. Oops, I don't want to do that. I just want to do Control S to save. And that's basically it, I think. I was able to, without really doing any typing at all, create a very nice GCSE math module that actually used the built-in math module of Python. The difference, I should maybe call it like math formulas or something like that. I've called it Math GCSE, but the actual math module is, I wonder if we got, no, you won't have math.c for the speed of light, but you will have things like pi in there. So like, you know, that's an attribute of the math module. So our math GCSE module has an attribute of the speed of light. Too complicated, really. I could have changed this to 3 million. So you know, I could have done over here underscore, just to separate the zeros, 000 underscore, in fact, change this to 000 underscore, and now change these to, I'm going to actually move the underscores away. 00. Let's put that one over there. X, B, and that should have been a 3, not a 2. And so I think it is that's basically rounded because we're GCSE. So, and this is the very last number, it's just a very, very, very big number. There we go. And I believe that's pretty much it. I didn't even use a very large number anywhere, or at least find the very large number. Let's just see. I've only used it in one place actually. I was going to return a very large number somewhere down at the bottom, so I've forgotten to do that. Calculate the time given distance and speed. So speed was 0. This was return very large number. There we go. Otherwise return distance over speed. And Python's quite nice in terms of its like looks for this kind of thing. Like it returns here, so it breaks early out the function if the speed equals 0. Otherwise it doesn't. So I never had to put an if statement in, like a second if else. I could have put else in here, but it wasn't necessary. So I could have put an else in here. So this is like a nice pattern, right? That you don't have to, like this is a convention, it's no, so it's quite cute or easy looking, so we'll give it that. And I think that's it. I'm going to call it the end of this little video. It was really a video on how to create an entire module with doc strings. I could have done even more. In fact, just here I'll put I don't know what this is actually called at the top. Z, there we go. So something like Control I, description. A brief summary description of this module. Let's just see what happens. Okay, except I think I want that to be sort of like X at the top before anything was actually called, and we'll hit S to save it again. And if I go to the test math, I just wonder at the top if I hover over it. Yeah, there we go. It's kind of like Math GCSE. This module provides a collection of mathematical utilities and formulas commonly used in GCSE level mathematics. It includes functions and classes for calculations involving geometry, algebra, physics, and general mathematics features. Right. I don't know this bit here where it's got the features, so I shall go over here and interesting that it does that. I wonder if I put that space in there and then hit Control S, it just goes back, because it's kind of like, yeah, it's a little bit nicer. C is the speed of light in a vacuum. You know, if that number's wrong, you post that in the video, or like make your little comments or whatever. Very large number, a placeholder for extremely, it's kind of like it knows, it's really nice, the placeholder for extremely large numbers. This module is designed to be, and then finally, a utility for educational purposes and basic math calculations. So, although that was like, you know, I'm not sure that end piece was needed, but you know, credit to the AI, it's done a lot. I've left it in there anyway. This module is designed to be utility for educational purposes and basic math calculations. That's some sort of caveat. I don't know. I wonder if I can put like. See what happens there. Yeah, it's kind of like, oh, nice. Although it's done that over on that bit there, so. There we go. A little bit nicer. It uses the backticks for some things. I'm just going to hit save, go back, hover over. Hey, okay, so the double, the thing over here, the equal signs, it's kind of raised it to a title, but actually I don't think I want the title thing to look like that, so I'll remove that there as well. So it's just that, basically. Hit save. I don't need to have that piece in there. It's just now this just looks, but you get this nice type hinting and everything. Like the documentation is written for you effectively. Oh, look, I know that. Yeah. So classes begin with capitals. So that's quite nice. So these are all the classes. It actually says class as well. For solving problems involving speed, distance, and time. So like all of the docstring stuff is, yeah, it's kind of like all there. It's nice. Yeah, I think that's it. Got a really nice, well documented little math GCSE.py thing. It could have been created a lot quicker. I just went in and like learned some extra pieces, reminded myself of some extra pieces, and used the Python or the AI and actually the linters to help a bit, because it helped us on this physics thing somewhere. Where was it in the physics thing? Force, mass, and acceleration. It went in and corrected it, updated the force equals, double equals none to is none for our proper tests. And, you know, I guess I could, like, this is an example of just one other bit, basically, but in here, I guess, editor inline chat. I did try to just copy that. I didn't copy and paste. I thought paste. Oh, there we go. Okay. Let's just see what it's got to say about that. Copilot working. This snippet of code is part of the force mass acceleration function with calculator. Okay, the condition check. Check the force is none. Block checks if the force parameter is not provided, i.e. none. Now I wonder what, like, well, I guess double equals means check if it is actually equal to none. So, you know, I won't go into the semantics of it. So, but yeah, we were able to learn little extra bits as well, like go with the AI, go with the linters. They make your code better, basically. They certainly make my code better. And yeah, I think that's pretty much it. Maths GCSE. If you like this video, hit the like button, the follow, subscribe button. If you have any comments, definitely you know, say something about comments. What else can I say? If there's any errors in the code, that's what I was going to say actually. If there's any errors in the code, because I was going fast and this is all live streaming, then have a mention on that. Otherwise, I think we're done. So yeah. Oh, and there's a little I don't know how to show that, but in the like bottom right hand corner of the video, there's a little QR code thing. You can go onto that, because that will take you over, and you can go onto that and actually contribute. And I wonder if it's in there somewhere. So there we go. Yeah, you can contribute Bitcoin payments. Boom. I think it was the Bitcoin payment one. Yeah, you can send a fraction of a Bitcoin there. No, it's in the whole Bitcoin there. It's the Bitcoin payments. Yeah. Anyway, yes, kind of like it keeps things going if it's done. But in reality, if you do like the video, yeah, just subscribe, like, follow, and all the rest. And I might inside the little Python site here, I might make, I guess, I should be making an AI section. So maybe that'll be next. There's some links to, I was presuming, various Python coding videos. Oh yeah, it is. And yeah, some of my videos. There's actually tons of the videos here. So